Okay, we're here to do a quick review on sketching linear graphs. This is something that we did back in grade 9, so let's run through this. We first know that linear equations have a general form, a standard form, and it is y is equal to mx plus c. Now we know a couple of things about this general form, this standard form. We know that the m is equal to the gradient and that the c is the y-intercept, where x is 0. Okay, so if we have that as an understanding, we might be asked to do a couple of different things. So let's have a look at the things that we might be asked to do with our understanding of these linear equations. Okay, first things, we might be asked to plot a linear equation. Now, in this instance, we're not given any values of x and y, so we would need to come up with some values of x and y. Here, I've just picked some values. You would then substitute in your values of x into the equation and calculate what your values of y would be. So here, I know that I would be able to say that this one here would be negative 11. When x is equal to 0, it's negative 5. And when x is 3, it would be 1. Okay, once we have that, we have a set of points that we can then graph. Okay, so I'm going to just zoom this out just slightly so I can still see that when I get into where the actual graph is. So we know about graphs. We know how they work. We know that there is a y-axis in that direction, and we know that there's an x-axis in that direction. It goes on forever. So we know to plot our points that we've just figured out. We know that we're looking for negative 3, 11. So negative 3, 11 will be about here. Now it's slightly inaccurate because I'm zoomed out a bit so I could fit it all on the screen. I also am going to need 0, negative 5, which would be right here. And I'd need 3 and 1. So 3 and 1 would be about there, I'm guessing. You should come in here, now that I've drawn that, I'll zoom back in a bit. You should draw in the names of those points. This was negative 3, negative 11. This one was 0, negative 5. And this one was 3, 1. Then with a straight line, and I'll need to move mine a little bit, we can join all of those points together. You put a straight line through it. You can't shift your line once you're done, but I can, and I will, just so it fits a little nicer. You then put arrowhead pointing off into the distance because that goes on forever. And we should also name our linear equation. In this instance, it was 2x minus 5. So this is y is equal to 2x minus 5. That's the name of that linear equation. Okay, so we've done plenty of them. I'm hoping that you remember how we graph, plot a linear equation. Okay, so very good. That's our first reminder. Next thing we're going to do is we might actually need to go back over our y and our x-intercept model. Simply because you might need to, instead of writing up that graph, you might be asked to find the intercept. So we want to sketch this. 2x plus y equals 6. Now, we need to find the y-intercept first. The y-intercept is when y is equal to 0. So we can just work that through. I'm not going to take much time stepping you through this. But we can calculate and slowly work down, get x by itself, that x-intercept, x is equal to 3 when y is equal to 0. So therefore our x-intercept, which is missing a dot over the I, whoops, there we go, that's better. Our x-intercept is 3, 0. Okay, we then do the same thing for our y-intercept. When x is equal to 0, calculate the value of y, and that gives us 2 points, 3, 0 and 0, 6. So once again, we come down into our Cartesian graph, and we are going to find the point of 3, 0, which was right there, and that is 3, 0, and we want 0, 6, which is just there, 6, oh, sorry, wrong way around, 0, 6. We then get our handy dandy ruler, and I will move mine when I can fit it a little bit better. Okay, I've drawn him in. I'm going to have arrowheads on either end of it. There we go. I'm going to need my, to name this, and this was 2x plus y equals, or I forget that last bit, 6 equals 6. Is that what it is? 2x plus y equals 6? Yeah, there it is. Sketch 2x plus y equals 6. So I can say that this is 2x plus y equals 6. And now I've sketched my based on the y and the x intercepts. Okay, so that is something that we have also done. Next thing in our review is the gradient intercept method. Okay, very good. We can talk about that. We want to plot this. We want to plot y is equal to 2/3 of x minus 3. Okay, well, we know a couple of things about this already. We know that the minus 3 will be our c value, which makes our y-intercept 0, -3. The other thing we also know is our m. We've been given our m. Now, remember that there's two numbers. The top number, the numerator, is the rise or the change in the y-intercept, and the run is the change in the x-intercept. So we can draw up our good old Cartesian plane. Here it is here. We can put these points in. Oh, I'm going to need a little bit more space just so you can see what's going on. I've already drawn in my 0, -3. That is my y-intercept. So all I really need to do is I need to think about, well, what will be my gradient? I know that the rise changes by 2 and the run changes by 3. Okay, so I'm going to change, and it's not a negative gradient, so I know that it will be heading up into this direction somehow. So let me think about where it needs to go. So if I change my rise by 2, so I go up 1 and then up 2, and then I change my run by 3, so from 0 I'll go 1, 2, 3. This point right here will fit on my linear equation. I then grab my ruler and I can rule in that line. I can then put in my arrowheads, and I can say that this is equal to y is equal to 2/3 x minus 3. And I've just drawn that based on a gradient intercept method. Now, these little bits here, you don't have to draw those in. If it helps you draw those in, you can. Oops, I moved the graph. I do think it makes it a little bit messy, but you can do it. It's up to you entirely, okay? All right, so there is a quick little review of some of the stuff that we have done with our linear equations. Oh, but hang on. This m here, it was a nice fraction already. It was 2/3, so I could find my rise over my run. What happens if I don't have a gradient? If I've just got a gradient of 4, well, what is my rise and what is my run? Well, any number by itself can be made a fraction if you put it over 1. So don't forget that. You could always have a run of 1 and a rise of 4. Okay, so that's our quick review on linear equations and how we graph them from different methods.